So the question is to derive the following. dH is equal to TdS plus VdP is equal to CpdT plus bracket V minus T times dV over dt at constant P, all of that times dP. So if we want to derive the following based on enthalpy, the first thing that we have to do is that we have to identify what the enthalpy is a function of. So we can either make it a function of temperature and pressure or temperature and volume. In this case, I'm just going to make it as a function of T and P, so temperature and pressure. So what we have is that we have H as a function of T and P. So after doing that, we want to apply one of the rules, and this rule is called the total differential, which is shown right here. So using this, we can identify the f, x, and y. So we know that f is equal to h, x is equal to t, and y is equal to p. So knowing that, we can just plug in the variables into the total differential, and here is what we will have. We will have dH is equal to dH over dt at constant p dt plus dH over dP at constant t dP. So after knowing this relationship, we can solve for the right-hand side and see what it will be equal to. So using one of the heat capacity relationships shown at the bottom right here, you can see that we have one of the same terms right here. We have dH over dt at constant P, which is shown right here. And we have also one of the heat capacity terms is the same thing as dH over dt at constant P, which is shown right here. So we know that this is equal to Cp right here. And for this one, we don't really have any specific relationship or even the Maxwell's relation, so we have to solve it by plugging in the definition of dH. We know that the definition of dH is right here. So we know that dH is equal to TdS plus VdP. So if we take the dH right here and we plug it in to the dH right here, let's see what we will be having. So we have, again, we can plug it in right here and we'll have TdS over dP at constant T dP plus VdP over dP at constant T dP. And again, we still have our left-hand term, but this is all pretty much equated to dH of dP at constant T times dP. So what we know right here is that we know dP over dP will be equal to 1. We also know that ds over dP at constant T is one of the Maxwell's relationship. And we can look at one of the Maxwell's relationship at the bottom right here and see which one it will be equal to. So S, P, and T. So we can see that it is the same thing as right here for one of the Maxwell's relationship. So we have ds over dP at constant T is equal to dV over dt at constant P, and don't forget the negative sign. So if we utilize that equation, we will be able to plug in and solve for this portion right here. So for this portion, we will get negative dV over dt at constant P. So understanding all of that, we can pretty much solve for the final equation. So let me rewrite all of this, and we will be having dH is equal to Cp dt from the above right here. This will be equal to negative T dV over dt at constant P dP plus VdP. So based on this, we can see that we have a similar terms, so we have like a similar dp right here. So we can use that and factor that out. So to continue on, again, we can factor that out and solve for the final equation. So we have dH is equal to Cp dt. So instead of writing a minus, we want to have it in similar terms right here. So we want to use a plus sign instead, a plus sign right here. So I'm just going to write in a plus sign and then bracket of the volume minus the temperature dV over dt at constant P, and all of that is multiplied by dP. And if we take that equation and we compare it to the top equation right here, we see that we have the terms Cp dt plus V minus T times dV over dt at constant P times dP, which is the same thing as what we have at the bottom right here. So we do have dH and Cp dt plus V minus T times dV over dt at constant P times dP. So that is how you solve for this relationship, and we can see that the final equation will be equal to this, and we can utilize our knowledge of total differentials, heat capacities, and Maxwell's relationships to finally solve for this final equation. So there you have it, and goodbye.